The planet Uranus has an elliptical orbit that is nearly circular, with A equal to 19.18 and B equal to 19.16, where units are astronomical units. 1 astronomical unit equals 93 million miles. A. Graph the orbit of Uranus in negative 30, 30, 10 by negative 20, 20, 10 window. Plot the point 0.9, 0 to show the position of the Sun. Assume that the major axis is horizontal. B. Find the minimum distance between Uranus and the Sun. So we know the orbit is elliptical, and here's our respective values of A and B, and we know the horizontal axis is the major axis, so our equation of the ellipse would be x squared over 19.18 squared plus y squared over 19.16 squared, and that's equal to 1. In order to use the calculator to help us solve this, we need to solve for y. Then that means first let's subtract the x squared over 19.18 squared from each side. So y squared divided by 19.16 squared will equal 1 minus x squared over 19.18 squared. Next, we would have to multiply both sides by the 19.16. So y squared will be equal to 19.16 squared times, and now put it in parentheses, 1 minus x squared over 19.18 squared. Now we would take the square root of both sides. When we take the square root of both sides, we have to put the plus or minus on the right-hand side. Now, of course, the square root of y squared is just y. So we have solved for y, and it's giving us two equations, the version with plus and the version with minus. So let's write what those two equations would be to enter them into the calculator. It would be y sub 1 equals, we'll take the positive square root first. Now, I want you to notice that we can take the square root of 19.16 squared, and of course that's 19.16. However, that's the only simplification we can do inside the radical. So that leaves us with, inside the parentheses, 1 minus, and now I'm going to put this in parentheses, x squared slash 19.18 squared. And that's just to make sure that we're accurate when we enter it into the calculator. Now, y sub 2 will be that equation with a negative sign in front of it. So, negative 19.16 times the square root of 1 minus parentheses x squared divided by 19.18 squared. So now, let's go enter those into the calculator so that we can see the graph of this ellipse. So we're going to use the calculator for two different purposes. We want to graph the point 0.9, 0. Let's do that one first. To do that, we need to press the Stat key, and then it's on the word Edit, so and that's what we want, so press Enter. Now, we want to enter the point 0.9, 0. Right now, I'm in the list 2. Let me use the left arrow key to move to list 1, where I enter 0.9, press the Enter key. Now, let's move to list number 2, and the corresponding y value is 0, so press 0 and Enter. So we have our point in there, 0.9, 0. To actually plot that point, we use second stat plot. We are interested in the first plot, which it's labeled right here. So we press Enter, and now we want to turn that plot on. You can see it's blinking on the on, so press Enter, and now the stat plot for plot number 1, which was representing that point, is on. We want the scatter plot as the type, and that's what's selected already. The X list is list 1, so that's correct, and the Y list is list 2, so that's correct, and we'll just use the square as the little mark. Before we graph that, remember that we're supposed to use a particular window, so let's press window and adjust it. Remember, the minimum value is supposed to be -30, so we enter -30, press enter. For the maximum X value, it's +30, so press 30, 30, and enter. The scale is to be 10, so we'll press 10, enter. For the minimum Y value, it's -20, enter. The maximum Y value is +20, enter. And the scale is 10, and enter. Let's just graph that 1 point. And you can see now that that 1 point is slightly to the right of the origin, and that represents the sun. 0.9, 0 is where the sun is relative to when we will about to draw our orbit for Uranus. Now we'll enter the equations. We use the equation editor or the y equals key. Our first equation, y sub 1, is 19.16 times the square root, so we press second square root. Notice that it has a parenthesis in there, inside which we put 1 minus, and now this next expression, x squared over 19.18 squared, I put it in parentheses just to set it off from the rest of it. It's not necessary with respect to the order of operations, but it doesn't hurt to do so. So I put an open parenthesis, then the x variable, followed by the x squared key, then divide by, and then 19.18, and that has to be squared, so press the squared key. Now I'm going to close the parenthesis for that part of the expression, but then also close the parenthesis for the square root. The second equation, we press the down arrow key to get to y sub 2, and it's the same equation, just with a negative in front of it. So we press negative 19.16. Now for square root, we press second and square root key. We see the open parenthesis, we enter 1 minus, and again, I put this next expression in parentheses, so open parenthesis, x, and then the squared key, and then the division key, and enter 19.18, but that has to be squared, so press the squared key, close the parenthesis for that short expression, and then close the parenthesis for the square root. Now remember, the reason we're doing this is in order to graph it, we have to graph the top half of the ellipse as the positive square root and the bottom half as the negative square root. We press graph, we see our sun in the middle, then we're seeing the top half of the ellipse, and now the bottom half of the ellipse. So that would represent the orbit of the planet Uranus and the sun in the center. Now for part B, it asked us to find the minimum distance of the orbit between the sun and the orbit of Uranus. And what I want to point out is that minimum distance would have to occur, of course, when Uranus is closest to the sun. And since the sun is at 0.90 along the x-axis, the minimum distance will occur along that x-axis. In other words, it'll occur from 0.9 all the way out to 19.18, which is, again, the value of the vertex of this ellipse out along the x-axis on the right. So now let's go to the board where we can actually do this calculation to figure out what that minimum distance for the orbit is. So let's do that calculation on the board. It's 19.18 minus the 0.9, and that's equal to 18.28 astronomical units. But remember, 1 astronomical unit is 93 million miles. So therefore, if we were to multiply 93 million times the 18.28. That works out to approximately 1,700,040,000 miles.